Good morning, or good evening, or good afternoon, whatever time you are watching this video. For me, it's about 9:30 at night. And yesterday, or whenever you watch the last video, really, we started talking about sequences and series. We didn't talk about a specific kind of sequence yesterday, but today we will. Today we're going to talk about the arithmetic sequence. Looks like the word arithmetic, pronounced arithmetic. It says, in an arithmetic sequence, the difference between consecutive terms is constant. Remember, consecutive just means one right after the other. So basically what it's saying is to get from one term to the next term, we're going to add the same number every time. It says the constant difference is called the common difference and is denoted by D. So if I am going up in numbers and they're increasing by 5 every time, then my value for D, which is the common difference, is 5. If my numbers are decreasing and maybe they're going down by 3 every time, then my value for D would be -3. So if you have a positive value for D, then your sequence is increasing. If you have a negative value for D, your sequence is decreasing. But again, we are adding the same number every single time. That's what makes it an arithmetic sequence. So A for add, A for arithmetic. So example 1, we're just going to determine whether or not these sequences are arithmetic. And if they are, we'll just be able to prove they are by saying what D is. So in letter A, we have -3, 1, 5, 9, 13, ... because the sequence could continue. So do we see a theme where we're going to add the same number every time to get to the next term? Absolutely. Our value for D would be +4 because we're adding 4 each time. So yes, this is an arithmetic sequence. Let's look at letter B. Again, are we adding the same value every time to get to the next number? Well, to get from 2 to 5, I would need to add 3. To get from 5 to 10, I would need to add 5. To get from 10 to 17, I would need to add 7. And to get from 17 to 26, I would need to add 9. There's a pattern, but it's not an arithmetic sequence because they're not adding the same number every time. So it is a sequence. There's a pattern to these numbers, but it's not arithmetic. Letter C, we have -10, -6, -2, 0, 2, 6, 10. So to get from -10 to -6, we would add 4. To get from -6 to -2, we would also add 4, so that's looking promising. To get from -2 to 0, we would add not 4. We would need to add 2, and that's where it changes for us. So this is also going to be another no. This one is not an arithmetic sequence. All right, letter D, for some reason, these numbers got chopped off. So we have 5, 11, 17, 23, 29, ... All right, so to get from 5 to 11, we would go up by 6. 11 to 17, also going up by 6. 17 to 23, going up by 6. And 23 to 29, you guessed it, we are going up by 6. So our value for D, the common difference, is a +6. And yes, this is an arithmetic sequence. All right, next we have a formula. This formula is going to help us be able to write an equation so that we can find the nth term of an arithmetic sequence. Now, in order to use this formula, there's a couple things we need to know. First of all, we need to know the first term. That's what A sub 1 represents, and we talked about that yesterday. We need to know what n is. So are we trying to find the 4th term? Are we trying to find the 20th term? Whatever the number of the term is that you're trying to find, that's the n. And then the last thing that we need to know is we need to know what the common difference is. And if we know those things, then we can use this formula. You guys do need to learn, memorize this formula, so maybe put a star beside that. That's something you need to know. So next example says write a rule. In other words, write an equation for the nth term of the following sequence, and it's 50, 44, 38, 32, dot, dot, dot. All right, so write a rule for the nth term. So for this particular one, we do not know the n. We're trying to come up with an equation that we could use anytime, regardless of what n is. So we will continue to have n as a part of this answer. We do know what the first term is. We can see it in the sequence. It's a 50, and we can figure out what the common difference is. So what's going on to get from 50 to 44, and from 44 to 38, and from 38 to 32? It's going down by 6, and so that means our common difference is a -6. So I'm going to plug all of this information right on into the formula. So in place of a sub 1, I'm going to put 50, and I'm still using the n because we don't know it. And in place of d, I'm going to put a -6. Now you'll notice that I put a parentheses there, or if you don't put a parentheses, you might put a dot for multiplication to just make sure that you know that that is not subtracting by 6, because we're going to have to take that -6 and distribute it to what's inside the parentheses. And some people might be more comfortable with putting the d in front of the n-1. So you can put it in the front or in the back. It doesn't really matter. If you prefer to put that variable d in the front, that's fine too, if you like to look at that better that way. All right, so we have 50 plus, now we're going to distribute that -6. So -6 times n is -6n, and -6 times -1 is +6. And now we can combine like terms. I'm going to, well, it doesn't really matter what order you put it in, to be honest with you. 50 plus 6 is 56, and then -6n, or if you want to write it in descending order according to the exponents, then you could write -6n plus 56. But either way, that would be our rule. So if we were trying to now find the 32nd term, we could plug a 32 in for the variable n. All right, so example 3, the directions are the same. We're going to write a rule for the nth term. So again, we don't know what n is. We do know that the first term is 32, and we can find the common difference. So we're going from 32 to 47, and then to 62, and then to 77. So these are going up. That tells me my common difference is a positive number, and that's going to be a +15. So I have a sub n equals, I'm going to plug the 32 in place of a sub 1. So I have 32 plus parentheses n minus 1. Man, I like to break lead. Onto 15. And now I'm going to distribute the 15. So 15 times n is 15n. 15 times -1 is -15. And then I'm going to combine like terms. 32 minus 15, that'd give me 17. So 17 plus 15n, or if you'd rather write 15n plus 17, that's fine as well. All right, example 4 says to find the first 6 terms and then find the 300th term of the arithmetic sequence. So they're already letting you know this is an arithmetic sequence. That means that it's fine that we only have 2 terms. We'll be able to find what D is because they're already letting you know that it exists. So looking at these numbers, it's going from 13 down to 7. So that tells me that my value for D is a negative number because my numbers are decreasing and I'm going down by 6. So I know the value for D. I also know, well, let's just get going. So find the first 6 terms. So we have 13, that's the first term. We have 7, that's the second term. I'm going to continue to use the common difference of -6. So if I go down by 6, I'm now at 1. So now I have the third term. If I go down by 6 again, we now have -5. So we have the fourth term. I'm going to go down by 6 again. We have the fifth term. And then I'm going to go down by 6 one more time. And we have the 7th term. So we have done the first part of the problem. We found the first 6 terms. But now it's asking us to find the 300th term. And I certainly don't want to keep subtracting 6 hundreds more times. So this is where we're going to go to the formula. Now I have that n is a specific number. It is going to be 300. So I'm trying to find a sub 300. I'm trying to find the 300th term, and I'm using the formula. So I need a sub 1, which is the first term, which is 13, plus parentheses n minus 1, so 300 minus 1, and then times the common difference, which is -6. So let's do some basic math together. 300 minus 1 is 299. We're going to multiply 299 times -6, and that is going to be -1,794. And then we're going to add 13 and the -1,794 together, and that is going to give us -1,781. So we found the first 6 terms, and we found the 300th term. So again, we're just really using that formula. That formula comes in handy. Example 5 says the 11th term is 52, and the 19th term is 92, and we're being asked to find the 1000th term. So let me bring your attention real quick to the formula that we have learned today. And remember, we said that this particular formula, if we're going to use it, we need to know the first term. We're typically going to want to know what n is, and we need to know the common difference. There's a slight issue with this particular problem, and that is we don't know the first term. We know the 11th term, we know the 19th term. We don't know what the first term is, and we also don't know what the common difference is. But what I want to bring your attention to is if you look at this formula, you'll notice that this subscript of 1 is the same thing as this number 1 that's in the formula. Well, I don't know the first term, but what if I knew any other term in this sequence? I'm going to call it K. Okay, maybe it's the second, maybe it's the 8th. I don't know. It's another term. I'm going to replace those 1s with a K. So I noticed that those numbers were the same. I'm going to replace them with another variable because we might have a different number term that we know. And that's where we're going to now be able to use this problem. So we have 2 terms, right? We have the 11th term is 52, and we have the 19th term is 92. So the one that comes farther in the sequence is the one that you're going to call n, and the one that comes earlier in the sequence is going to be the one that you call k. So for this particular problem, n is going to be 19 because it comes farther in the sequence, and 11 is going to be the k. And just think about this. K comes before n in the alphabet, so this one needs to come before this one. All right, so that means I'm going to plug in that 19 for n. I'm going to plug in the 11 for k. I'm going to do the same thing here. I'm going to plug in the 19 for n, the 11 for k. Now, what is the 19th term? Well, they told us it's 92. What is the 11th term? We were told that it is 52, and 19 minus 11 is 8. And now we're going to solve and find the common difference. So I'm going to subtract the 52 over to the other side. 92 minus 52 leaves us with 40. And when we divide both sides by 8, we find out that the common difference is 5. So how does this help us? Well, now let's go back to this new formula right here. That, again, you might want to learn that one. It's almost identical to this one. We just took out the 1s and we put a k in its place. I'm going to go back real quick to that formula. So let me just rewrite it. All right, because what is it that we want to find? We want to find the 1000th term. So as we reuse this formula, this time I'm going to put n as 1,000. I'm going to continue to put k as 11. Could we have used the 19th term there? Sure, you can pick what you want. I'm just going to stick with what we already had there. So in the parentheses now, instead of 19 minus 11, we're going to have 1,000 minus 11. So 1,000 minus 11. And now we know that the common difference is 5. So the 1,000th term is going to be equal to the 11th term, which we know is 52, plus 1,000 minus 11, which is 989 times 5. 989 times 5 is going to be 4,945, and we're going to add 4,945 to 52, and we're going to get 4,997. And there we have the 1,000th term. So we need to know this formula. You also need to be comfortable with taking out the ones and putting k's in their place. In the chance that you don't have the first term, you have some other numbered term, and you need to be able to find the common difference. All right, partial sums. So remember we talked about partial sums yesterday. We said that S stands for those partial sums. So if you had S sub 2, that means you need the first two terms and you're going to add them together, or S sub 11, you need the first 11 terms and you're going to add them together. But when we have an arithmetic sequence, rather than writing out all of the terms and adding them together, we actually have a faster way to do it. We have two formulas that we can use. And the difference between the two is kind of depending on what information you're given in your problem as to which one would be the easier one to use. So for this particular one, if you're going to use this formula, obviously you need to know what n is. You also need to know what the first term is, and you need to know what the common difference is. The other formula, you need to know what n is. You need to know the first term. And what would a sub n represent? It would represent the last term. So the a sub 1, that you need to know the first term. A sub n, you need to know the last term. So it really is going to depend on what information you're given as to which one of those would be the easiest one for you to use. So let's, there was something I wanted to say, except my brain just froze up. What did I want to say? I don't know. Okay, never mind. All right, example 6. Find the sum of the first 40 terms of the arithmetic sequence 3, 7, 11, and 15. ... Okay, so I know the first term. I don't know the 40th term in the sequence. So I'm going to go with this one right here. Okay, so I'm going to be finding S sub 40. So that means that n is 40. So n over, well, let me just write the formula down first. I like to write formulas down first. First of all, the more you write them down, the faster it's going to be for you to learn them. Okay, there it is. All right, so we're going to find the 40th, the partial sum of the first 40 terms. So n is 40. So I'm going to do 2 times a sub 1. So the first term is 3. Again, n is 40. And I should be able to identify the common difference in this problem because my numbers appear to be going up by 4 every time. So the 4 is what I have for D. So 40 over 2 is 20. Inside the brackets, 2 times 3 is 6. Inside the parentheses, 40 minus 1 is 39. I need to multiply that 39 times 4, and that's going to be 156, which I'm now going to add to the 6, and that's going to get me 162. And let's see, that's going to be 3,240. So that would be the sum of the first 40 terms in that sequence. Now, one thing I want to show you real quick. Let's say you take quiz, test, whatever, and you don't remember this formula, but you remember the other formula. No big deal. You just have a little bit of extra work to do. So you know the first term, you don't know the last term, but can you find the last term? Sure you can. Again, this is going to go back to the first formula that we learned today. So we need to find the 40th term. We know the first term is 3. We know the common difference is 4. So 40 minus 1 is 39, and then we're going to multiply 4 times 39, and we are going to get 156. And then when we add that to 3, we get 159. So now we could go to the other formula, because let's say we forgot the first formula. So we would have 40 times, now in parentheses, we're going to do first term plus last term divided by 2. So 3 plus 159 is 162. 162 divided by 2 is 81. And if we multiply that together, we're going to get the same exact answer. So again, if you don't remember the other formula, that's okay. You can find the last term and then use this formula. Another thing you can do, I know I'm taking you off here a lot. Let's say you remember this formula and you don't remember that one. At this point right here, a sub n, you can plug in the formula for a sub n, which is a sub 1 plus n minus 1 times d. You all with me? All I did was I took a sub n and I plugged it in with the formula for a sub n. And now you can see those two are like terms. So that gives us 2 of those a sub 1s. We still have the n minus 1 times d. And then that 2, if I move it on out there, it's in the denominator under the n that was already there. You can get to that formula if you would prefer. So lots of ways you can do these problems. All right, almost done with these notes. Example 7 says, find the sum of the first 50 odd numbers. So obviously we have 1, 3, 5, ... So we know the first number. We can figure out easily that the common difference is 2. I'm gonna stick with the first formula, particularly because just a moment ago I showed you how you could derive that formula. So we want to know the sum of the first 50 terms. That means that n is 50. We know that the first term is 1. Again, n is 50. And we know that the common difference is a positive 2. All right, so 50 divided by 2 is 25. In the brackets, we're going to get 2 plus 50 minus 1 is 49, and 49 times 2 is 98. And 98 plus 2 is 100, and 25 times 100 is 2,500. So if you added the first 50 odd numbers together, that is the number that you would get. All right, last example says find, or no, doesn't say find at all. How many terms of the arithmetic sequence 5, 7, 9, ... must be added to get 572? So they're letting you know that is the sum. Obviously, we know what the sequence is, which means you can find the common difference. These numbers are going up by 2. Not only that, but we know that the first term, a sub 1, is 5. So when the question says how many terms, that means that what we are trying to figure out is the value of n. We don't know it. So I'm going to go back to that first formula for partial sums, which is the one I just used in the last example. And the reason I'm using this one is I know the first term, I know D, and I know the sum. I don't know the last term. That's why I'm not going to use that second formula. And I also don't know n. So I'm going to plug in what I know. I know that the sum is 572. I don't know n. I know the first term is 5. Again, here I don't know n, but I know that the common difference is 2. So let's take a look at what's going on inside of the brackets. Obviously, 2 times 5 is 10. And then over here, I have to take the 2 and distribute it, right, to the n minus 1, which is going to turn that into 2n minus 2. So it looks like I can combine the 10 and the 2 together. So I'm going to have 8 plus 2n. All right, then I'm going to distribute the n over 2, which is like a 1/2 n. So n over 2, or 1/2 n times 8, that's going to give us 4, right? 4n plus n over 2, or 1/2 n times 2n, that's going to give us a 1n squared. So here we see a quadratic, right? Now with quadratics, how do we solve them? Well, we have to get one side equal to 0. So I need to move the 572 over to the other side. And as I do that, I'm going to go ahead and write it in descending order. So I've got n squared plus 4n minus 572. And I'm probably going to have to do some product chart. And this is one that we might not know off the top of our head, so we might have to brainstorm a little bit. So the sum is 4. The product is negative 572. All right, well, it's probably got to be kind of a bigger number, seeing that the sum is such a low number and our product is negative, so they need to be one of each sign, a positive and a negative. So 10 doesn't go into that. Let's see, would 12 go into that? 12 would go into 57 4 times, giving us a remainder of 13, then bring down the 2, and then 12 would go into 1. No, that is definitely not right. 12 would go into that, and then you'd have a remainder of 9. Sorry, bring down the 2, and then 12 doesn't go into 92 evenly. Okay, so 12 is not going to go into that. Would 14 go into that? 14 can go into 57 3 times. That would be 42. Then you'd have a 4 times, because that would be 56. Yeah, that's not going to go in there evenly. Let's see, 16. 16, no. 20, no. What about 22? 22 would go into that twice, which would be 44. Then you would have a remainder of 13, bring down the 2, and then that would go in there 6 times. Yeah, there we go. So 22 and a 26. Those multiply to get 572. We need a negative 572, so one of those needs to be negative, but the sum needs to be positive 4, so 22 will be the negative number. Okay, now we're talking. And our leading coefficient for both is a 1. So our factors are 1n minus 22 and 1n plus 26. And if we set each of those equal to 0, I'm going to get that n is 22 or n is negative 26. Now let's go back and see, what were they asking us again? Because at this point I've forgotten. And would those answers work? So the question is, how many terms? That's why we were trying to solve for n. Do both of those answers make sense? No way, Jose. Negative 26 would make no sense because you're not going to have negative 26 terms, but you could have a positive 22. So how many terms would there be? There would be 22 terms in this sequence. All right, so just to reiterate, you do have some formulas to learn. For sure, let's get this one memorized, because if you know this one, you can take the ones out, put k's in their place for the off chance that sometimes maybe you get a problem where you don't know the first term. Okay, that's easy to switch those ones out and put a k in its place. And then for the other formulas, it's up to you if you want to memorize both of them or just memorize one of them. You can utilize either one of them with information that you're given. I'll let you decide of those what you want to learn or memorize, but figure that out quickly, okay? And then in the next section, we will talk about another kind of sequence called geometric sequences. Now, a lot of this should be familiar because for those of you that had me last year for Algebra 2 Honors, we learned this stuff. So this, again, is just review. So get to remembering those formulas, and I will talk with you in the next video as we discuss geometric sequences.